Hey everyone! In this video, we are going to look at how to combine two vectors. We got a question here where a penguin has waddled 200 meters at 80 degrees from the x-axis. And I'm going to go ahead and underline what's important here. So we have 200 meters at 80 degrees from the x-axis, and this was the first trip that we took. It then waddles an additional 400 meters at 300 degrees from the x-axis. Solve the final displacement of the penguin. This is a typical combine vectors or add vectors problem. So what we're going to have is step 1. We're going to break the vectors. Break the vectors. And in previous videos, I've shown how to break vectors, but we're going to break the vectors into its left, right, and its up, down. Our left, right, our dx, our x displacement, is going to equal our first displacement times the cos of theta 1 plus our second displacement multiplied by the cos of theta 2. And what's great about using this equation is if that little penguin had decided to wander off again, we would simply add a plus third displacement cos 3, and if it wandered off again, plus fourth displacement cos theta 4. So the equation continues as far as we need it, but for the purposes of this, we're just going to do 2. Our dx is equal to 200 cos 80 degrees plus 400 cos 300 degrees. Where did these come from? The 200 is our first displacement traveled, 80 degrees, the first angle, 400, our second displacement traveled, 300 degrees, our second angle. And keep in mind that these thetas have to be measured as from the x-axis. These are standard angles. We can clean this up, and we are going to, I believe that you can put this in a calculator, you are going to get dx equals 234.73 meters. That is our left-right component now. We're going to continue and get our up-down component. We're going to slide this up, and we'll use those numbers again later, but not right now. And our dy, so our up-down component, is going to be our first displacement, sine theta 1, plus our second displacement, sine theta 2, and just like the first equation, if the penguin had decided to waddle off again or go somewhere, we could extend this equation indefinitely. It is identical to the first one, except with sines instead of coses. So 200 sine 80 degrees plus 400 sine 300 degrees, and we're going to get that our up-down displacement is negative 149.45 meters. What does the negative mean? The negative means down. Because our left-right was positive, we're going to move to the right. Because our up-down was negative, we're going to move down. Step 2. Step 2. Draw a right angle triangle. What's beautiful about this method is regardless of how many vectors we need to combine, at this point, we are going to turn it into a single right angle triangle. A single right angle triangle is all that we're going to be left with here. We start off at wherever we want to begin our origin. We first move to the right. How much do we move to the right? We are going to be moving to the right 234.73. I like to make like a big dot where I started, and that way I can remember where I started. Once we move to the right, we now have to follow our up-down component. So this time we're going to go down. If that had worked out to be a positive answer, we would go up. We went down how much? 149.45 meters. Had to check that one out there. So we went to the right, 234.73 meters. Then we went down 149.45 meters, and this leaves us with a beautiful little right angle triangle where the hypotenuse is going to be our displacement. Most folks see this now and they giggle because they're pretty comfortable with Pythagorean theorem, especially if you're at a point in math and physics where you're breaking vectors. A squared plus b squared equals c squared. We'll just label this c here. And our c squared is going to equal the 234.73 squared plus the 149.45 squared, and the power of calculators. We can knock this out, no problem. Pythagorean theorem is a joke for the clever little cupcakes watching this. 278.27 meters. And a lot of folks think they're done now, but they're not done now, because the final displacement of the penguin needs a direction. This is the magnitude. We need a direction. So we're going to put a theta into our right angle triangle. And because this is a right angle triangle, we can use right angle trig, SOHCAHTOA to get this. We know the opposite angle, or opposite side, sorry, and we know the adjacent side. So we can write tan of theta is equal to the opposite side, 149.45, all over 234.73. And again, we can knock this answer out, no problem, and we get theta equals 32.5 degrees. Almost done. Almost done. I am going to make a step 3, but I want to keep my triangle here so everyone can see, is make certain that your theta is from x-axis. Ooh, you see this 32.5 is actually down here, and if you sent off, a rescue chopper to go find the penguin at 32.5 degrees, you'd actually send them, like, up in that direction, and the penguin would be lost. It would be so alone. What we have to recognize is that this 32.5 is actually down from 360. This 32.5 is actually all the way around like that. It's 327.5. So our final answer in combining these vectors is the displacement of our penguin is equal to 278.27 meters at 327.5 degrees. And we can even add, if we need to here, from x-axis. And that is how we add vectors together, by breaking them into pieces, making a right angle triangle, and then solving the hypotenuse and the theta of the right angle triangle, keeping in mind, once you get that little angle of the right angle triangle, you have to solve its standard angle so that we send our displacement off in the correct direction and not just into quadrant 1. Thank you very much for watching. I hope this was helpful, and if you're looking for some practice questions with these, be sure to check out our worksheets over at Workshop 49. Thank you very much.